Welcome to this explainer. Today, we're taking a pretty complex integration manual and turning it into a crystal clear blueprint for a serverless search API. We are bridging two absolute titans of cloud computing, Java-based AWS Lambda and Amazon Elasticsearch. So if you've ever wondered how to securely and efficiently connect your serverless architecture directly to a massive search engine, you are in exactly the right place. Let's build this together. Okay, let's just do a quick flyby of our agenda so you know exactly where we're headed. We'll start by meeting the power couple, our core technologies. Then gather your tools, lay down that Java foundation, wire up the crucial security layer, and finally, handle execution and deployment. Let's kick things off with Section 1, Meet the Power Couple, where we introduce our foundational technologies. Think of this integration as a highly efficient two-part system. AWS Lambda acts as the tireless engine, while Amazon Elasticsearch operates as the lightning-fast brain, storing and analyzing all that data. Together, they let you query massive data sets without ever provisioning a single traditional server. Pretty cool, right? Let's zoom in on our engine for a second. AWS Lambda is a serverless computing service that runs your code in response to events. You basically hand it your application, and it automatically scales and handles tasks with zero server management on your end. But honestly, the best part? You only pay for the exact compute time you consume. So if your code runs for just 200 milliseconds, you literally only pay for those 200 milliseconds. It's wildly efficient. On the flip side, we have Elasticsearch acting as your super-powered librarian. It's an open-source, distributed search and analytics engine built to store and analyze petabytes of data in near real time. It's a foundational piece of the Elastic Stack, usually teaming up with tools like Logstash and Kibana to pull actionable insights out of mountains of raw data in mere milliseconds. Moving right along to Section 2, Gathering Your Tools, where we go over the prerequisites for your build. Before we actually write any code, you need to check off these 4 prerequisites. First, make sure you have an active AWS account to create your Lambda functions. Second, spin up an Amazon Elasticsearch domain in the AWS console. And hey, please make a very strict note of your cluster's endpoint URL. You are absolutely going to need that later. Third, get your local Java and Maven environment set up. Grab a coffee if you need to wait for those installs. And lastly, install the AWS command line interface so you can seamlessly talk to your AWS services. Section 3, the Java Foundation, setting up your dependencies and requests. The first step here is getting your toolbox ready by updating your Maven dependencies in your pom.xml file. You're going to need the Elasticsearch Java high-level REST client, the AWS Lambda Java core, and the AWS Java SDK. Just a quick heads up, make sure to use version tags that actually match your specific Elasticsearch version. Once that's sorted, step 2 is configuring your basic request. Using the request object in Java, you can spin up a simple GET request, like targeting your _index/_search, or even _cat/indices, if you just want to grab a list of your indexes. So we've got our engine ready to ask questions and our brain ready to answer them. But that brings up a really vital question. How do we safely connect these two powerful services? A search engine is incredibly capable, but it's a massive liability if anyone on the open internet can hit it. Which brings us to the most complex, but absolutely most important part of our whole blueprint. Section 4, Wiring the Security. This is where we handle authentication and interceptors. We're going to chunk this security wiring into 3 totally manageable steps: signing the request, attaching your credentials, and building the authenticated client. If you skip any of this, your Lambda function is just going to slam into a permissions wall when it tries to talk to Elasticsearch. This process right here is exactly how we bridge AWS's super strict identity and access management ecosystem directly with Elasticsearch's native REST APIs. Let's break it down. Okay, your very first line of defense is the AWS ForceSigner class. When you instantiate this and use set service name and set region name, you are locking in your specific AWS service and region. You're essentially prepping the exact cryptographic signature that AWS demands to prove your request is 100% legitimate. Next up, imagine an interceptor that catches your outgoing HTTP request right before it leaves Lambda. Well, the AWS request signing Apache interceptor does exactly that. It pairs the AWS static credentials provider with your basic AWS credentials, which, remember, contain your unique access and secret keys, to stamp that request with your authorized identity. It intercepts, signs, and sends it safely on its way. It's basically a highly trained bouncer for your data. Finally, step 3 binds the whole shebang together. You use the REST client builder to create an HTTP host, using that exact Elasticsearch endpoint URL I warned you to write down earlier. Then, you use set HTTP client config callback to attach the interceptor we just built. And boom! You now have one unified client with the proper security clearance to walk right through the front door. No more denied access errors. Section 5. Execution and deployment. It's time to bring your serverless API to life. These last 3 steps take us from running a local operation all the way to a rewarding final lap of deployment. First, you actually execute the Elasticsearch operation, say indexing a document or running a search, by calling build.performRequest. You pass in the request on your newly secured client and capture the response. Second, you compile the project and upload your packaged Lambda function jar files straight to AWS. And third, you create an API endpoint in Amazon API Gateway. This acts as the public-facing URL for your brand new Lambda function. But before we pop the champagne, here is a crucial pro tip straight from the source. Even though Lambda and Elasticsearch are whispering securely to each other behind the scenes, you still need to protect the actual front door from the outside world. As your final layer of protection, never forget to lock down that new API Gateway endpoint by configuring it with an API key right there within API Gateway. Seriously, don't skip that step. So you now have a fully secured serverless search architecture right at your fingertips, totally capable of chewing through massive data sets in near real time. But it does leave us with a pretty fascinating question to ponder. If this serverless brain can essentially scale infinitely to meet your data, what happens to your cloud bill when your data wildly outgrows your expectations? It's definitely something to think about. Until next time, keep building securely.